SASE is revolutionizing remote work by offering a cloud-based platform seamlessly integrating networking and security functions. This innovative approach enhances security performance and access for distributed workforces and paves the way for a more secure and efficient future of remote work. Studies show that SASE reduces security incidents by 25% and improves network performance by 20%, underscoring its potential to transform the remote work landscape. Hey everybody, don't forget to hit the like and subscribe if you want to see more content like this. Again, thanks for all your support. It's a huge help. Zero Trust Network Access, or ZTNA, is a game changer in SASE environments, fundamentally altering the traditional perimeter-based security model. By never assuming trust and always requiring verification, ZTNA ensures robust user verification and application access based on identity and context policies. This reassures organizations that their SASE environments are fortified with stringent access controls and user verification measures. A structured approach to ZTNA implementation begins with a clear assessment of your organization's protected surface. This refers to the areas of your network and data that are most critical and need the highest level of protection. Security teams should prioritize protecting these vital assets, applications, and data over defending a broad attack surface. This focus makes security and resource allocation more precise. Implementation usually involves several steps, which can be part of a structured approach. First, assess your organization's protected surface. Second, prioritize protection of critical assets, applications, and data. Third, implement ZTNA to enforce these priorities. And fourth, continuously monitor and adjust your security measures. SASE provides the cloud-native infrastructure for ZTNA implementation, connecting mobile users, branch offices, and cloud resources through a unified security model. Map transaction flows. Controlling your network requires knowing how data moves. Visualizing these flows with network traffic analysis tools can reveal vulnerabilities. So let's talk about micro-segmentation. You can use VLANs and software-defined networks to isolate your network, and this really helps prevent lateral movement after a breach. Establishing strong identity verification is crucial. You should use multi-factor authentication, or MFA, as a cornerstone of your ZTNA strategy to verify user identities before granting access. Also, it's important to use least privilege access. This principle basically means users should only have access to the applications and data they need for work. Enforcing this principle can significantly reduce the potential impact of a security breach, since attackers will have limited access even if they manage to compromise a user account. Now it's time to replace legacy VPN infrastructure. Traditional VPNs honestly provide excessive network access once authenticated. ZTNA, on the other hand, offers application-specific rather than network-level access, and it uses a lighter, more secure agent concept. And don't forget to integrate endpoint security. To prevent compromised devices from accessing your resources, you should integrate your ZTNA solution with endpoint protection platforms. Continuous monitoring is honestly a cornerstone of zero trust. It requires ongoing access control and resource isolation validation to maintain security. By emphasizing the importance of this practice, organizations can instill a sense of vigilance and proactivity in their security teams, making sure that potential threats are identified and addressed promptly. Before implementing ZTNA, organizations should, document application usage patterns to prepare for operational complexity. This preparation helps create access policies and reduce transition disruption. Cleaning up unnecessary access rights before implementation really simplifies things and reduces security risks. ZTNA provides secure application access without exposing users to the corporate network or the internet, which is a big benefit for remote workforces. This approach is helpful as organizations support distributed work models because it allows secure access regardless of user location, all while maintaining strict access controls. AI-driven threat detection, really transforms SASE environments. It rapidly and accurately detects and responds to security threats using machine learning algorithms. Unlike rule-based systems, AI-powered threat detection continuously learns from network behavior to identify security breaches. The SASE framework uses several AI mechanisms to improve security. Real-time threat prevention means AI systems continuously analyze network behavior to detect and mitigate unknown and evasive threats. This capability is especially valuable as cyber threats become more sophisticated and traditional detection methods, they just fall behind. Behavioral analysis is another key aspect. Instead of using threat signatures, AI analyzes network behavior to identify suspicious activities. This works against multi-stage attacks that might otherwise go undetected. Enhanced phishing detection is a big deal here. Machine learning algorithms analyze web page source code, images, text, and URL patterns to detect phishing attempts before users interact with malicious content. This kind of proactive protection significantly reduces a common attack vector. And then there's adaptive learning. AI systems learn from their data and adapt to changing threat landscapes without manual updates. This self-improving capability keeps security up to date against new attacks. When you combine AI with zero trust network access in SASE environments, security gets a real boost. AI makes ZTNA even better by, improving threat detection and response, analyzing contextual data, and validating user behavior throughout the session. Not just at the start, when you first authenticate. SASE with AI-driven anomaly detection can alert organizations to security threats, which is pretty important. The technology analyzes huge amounts of network data to establish operational patterns, and then it detects any changes that could mean there's a compromise. AI can also automate those initial response actions to quickly isolate and stop network threats. Plus, AI-powered SASE centralizes data collection, making security even stronger. These systems let organizations analyze and correlate security incidents across the board by storing network and security event data in a central data lake. Having this kind of holistic view really helps security teams spot attack patterns that might be missed if you're just looking at isolated events. As cyber threats keep getting more sophisticated, AI-driven threat detection gives organizations an edge by spotting security incidents earlier and with greater accuracy. This capability is honestly becoming more and more important as organizations move to distributed work models, which increases their attack surface and brings new SASE security challenges. Hypervisors create and manage virtual machines that provide security services across distributed networks in SASE environments. Hypervisors are critical to the SASE architecture and require specialized security. SASE deployments are multi-tenant, raising security concerns. Multiple organizations share cloud-based SASE infrastructure, creating isolation vulnerabilities if hypervisor security is compromised. This shared architecture makes hypervisor breaches high-value targets for attackers because they could affect many customers simultaneously. Confidential computing's hardware-based trusted execution environments, or TEEs, protect SASE components from unauthorized access, offering a promising solution. The operating system or hypervisor root user cannot inspect SASE process data because these environments encrypt memory. Even if the infrastructure is compromised, sensitive enterprise traffic and cryptographic keys are protected. In SASE environments, hypervisor security requires several best practices. Regular patching and updates are a must. Hypervisors need security patches to fix vulnerabilities, since unpatched hypervisors are a common attack vector. Effective virtual machine isolation prevents lateral movement between virtual environments, which helps prevent breaches and protects critical workloads. Strong authentication, including multi-factor authentication, restricts administrative access to hypervisor management consoles. Continuous monitoring is also key. Monitoring hypervisor activities helps identify suspicious behavior. And finally, critical component segmentation means SASE components are divided into security domains to reduce breach risk. So, remote browser isolation, or RBI, is another important SASE security layer. RBI works by isolating web content from endpoint devices, which helps prevent malware from reaching user systems. And according to Gartner, RBI actually neutralizes web-based threats, making it a core SASE capability. The complex interactions between the hypervisor and managed virtual machines, or VMs, often cause hypervisor vulnerabilities. These can include privilege escalation, side channel, and hypervisor escape vulnerabilities that allow attackers to, escape VM containment. These vulnerabilities should really worry SASE administrators because they could compromise distributed network security. Organizations implementing SASE should definitely evaluate potential providers' hypervisor security measures. Understanding patch management, isolation technologies, and confidential computing for multi-tenant environments is, essential. The hypervisor security affects the entire SASE security stack, making it absolutely crucial to security. Identity verification is central to SASE security architecture, ensuring only authorized users can access sensitive distributed resources. For robust identity verification, a multi-layered approach that balances security, user experience, and evolving threats is needed. Identity verification in SASE environments requires several fundamentals. Multi-factor authentication, or MFA, combines passwords, security tokens, and biometrics to strengthen verification systems compared to single-factor approaches. Risk-based assessment means organizations can scrutinize each access attempt by adjusting verification requirements based on location, device, and behavior patterns. Data privacy and security are also key, with encryption and secure storage safeguarding sensitive identity data used during verification. User experience optimization is important too. Minimizing friction while maintaining security encourages adoption and reduces workarounds. And finally, GDPR, HIPAA, and KYC regulations ensure legal compliance and data protection. Many modern SASE implementations use advanced technologies to verify identity. Biometric verification, for example, has really improved identity security by using unique, hard-to-replicate physical traits. AI-driven facial recognition systems can adapt to appearance and environmental changes by analyzing unique facial features. High-resolution image comparison of an individual's iris patterns provides accurate verification. Pitch, frequency, and tone analysis create biometric profiles for voice recognition. and the widely used fingerprint recognition method creates secure biometric templates from fingertip patterns. So, let's talk about machine learning and AI. AI improves identity verification by identifying patterns and anomalies in authentication attempts to anticipate fraud. It also enhances accuracy through learning from past verifications. And well, we use advanced detection algorithms to combat sophisticated threats like deepfakes. When it comes to verifying documents, advanced document scanning technologies are used to authenticate identification documents. OCR is used for information extraction and validation. We also examine security features like holograms, watermarks, and microprinting to detect tampering or forgery. Plus, there's support for various international documents, which is really important for global workforces. Now let's move on to SASE environment implementation strategies. Strategic planning and execution are needed for SASE identity verification. Integrating identity brokers is a key step. Identity brokers simplify authentication between SASE solutions and identity providers. They let SASE solutions support multiple identity provider authentication methods with one authentication protocol. Standardizing authentication across systems not only simplifies things, but also makes them more secure. So, let's talk about remote worker considerations. Remote identity verification can be pretty tough for distributed teams, right? Well, remote I-9 verification actually helps simplify onboarding and make sure you stay compliant with work eligibility requirements. Device enrollment should always verify both user identity and device integrity before granting access to any corporate resources. And, automated risk-based authentication can adjust verification requirements based on the risk profile of each access attempt. Now, when it comes to zero trust integration, identity verification is really the foundation of SASE zero trust security models. Using passwordless, phishing-resistant multi-factor authentication with cryptographic keys and biometrics gives you much better security than those old password-based systems. Continuous verification throughout the entire user session, not just at login, helps protect against account takeover. And on top of user verification, verifying device identity makes sure only trusted devices can get to network resources. Moving on to new trends and best practices, SASE identity verification is honestly evolving due to several trends. Document and biometric solutions from a single vendor now offer seamless verification and stronger security thanks to comprehensive authentication. Automated verification guidance also helps improve the quality of documents and selfies, which increases success rates and cuts down on user frustration. Custom workflows let organizations tailor identity verification to their specific use cases and risk profiles. By following these best practices, you can improve SASE security and make user access a lot smoother for legitimate users. As threats keep evolving, strong identity verification just has to protect SASE distributed networks and resources. So, micro-segmentation, it basically divides a network into these small, isolated application layer segments with, dedicated security policies and controls. Unlike traditional network segmentation, micro-segmentation actually controls workloads, applications, and virtual machines right at the workload level. Micro-segmentation, when it's integrated with other security functions in cloud-native SASE environments, becomes honestly really powerful. SASE micro-segmentation leverages cloud capabilities to adopt policies based on real-time context and identity, which is pretty different from SD1 micro-segmentation that's mostly focused on optimizing network paths. Now, why does micro-segmentation matter so much? Well, modern network security just requires it mainly because of its many security benefits. For example, micro-segmentation limits lateral movement within networks, so breaches get confined to specific segments. It also helps prevent network threats, kind of like how watertight compartments in a ship prevent flooding from spreading. Improved breach containment is a big deal. A micro-segmentation isolates security incidents, which really helps security teams respond faster and minimize damage. This containment capability is absolutely essential for keeping business running smoothly during attacks. On top of that, you get stronger regulatory compliance, isolating systems that are regulated by things like GDPR, HIPAA, and PCI DSS from the rest of your infrastructure just makes compliance so much easier. This kind of segmentation really helps define where your sensitive data and systems live. Micro-segmentation is honestly just essential to the zero trust architecture. It enforces the principle that network traffic should not be trusted no matter what. Verifying all segment communications really supports the never trust, always verify approach. Micro-segmentation protects cloud-native applications and workloads in hybrid and multi-cloud environments by providing consistent security controls across diverse infrastructure. Let's talk about some implementation tips for micro-segmentation. Planning and execution are, absolutely essential for micro-segmentation. It's best to install micro-segmentation in phases using a crawl, walk, run model. Start with zone-based network segmentation, then move on to application-based, and finally, granular micro-segmentation. Be sure to map your network architecture inventory and document your network architecture carefully. This architectural map really underpins effective security policies. Now, study traffic patterns before segmentation. It's important to identify daily workflows by studying communication and traffic patterns. This observation helps you create data center policies that secure east-west traffic without disrupting legitimate communications. Next, identify and attribute assets. Use application-based tags or labels to group assets like applications, servers, data sets, and users, and then write your policies. This approach honestly just makes security policies more flexible and maintainable. Before implementing policies, it's important to simulate their effects to find coverage black holes. We validate that micro-segmentation improves security without disrupting critical business functions. SASE environments should prioritize identity and context-aware security policies that dynamically micro-segment based on user identity, application sensitivity, and real-time risk assessment. This integration creates granular, adaptive access controls. SASE implementation should use cloud-native micro-segmentation to enforce policies at the network edge in distributed environments. This approach matches modern distributed workforces and cloud resources. Micro-segmentation creates highly specific security zones that limit lateral movement and contain threats, improving network security. As companies adopt SASE architectures, micro-segmentation helps provide more precise, adaptive security controls while supporting distributed work models and cloud-based resources. Behavioral analytics, which uses AI and machine learning to establish baselines of normal behavior and flag deviations that may indicate security breaches, has become an essential part of SASE environments. Behavioral analytics really improves SASE security in a number of important ways. First off, it performs multiple security functions in unified SASE. For example, with activity monitoring, behavioral analytics can detect anomalies, like accessing sensitive data at odd hours or from unexpected locations simply by continuously monitoring user activities. And when it comes to threat prevention, recent studies show that machine learning algorithms can assess behavior patterns to identify threats before they cause harm, which interestingly reduces security incidents by 45%. There's also adaptive authentication. Security systems can dynamically adjust authentication requirements based on risk assessments from behavioral patterns, so they'll add verification steps only when suspicious activity is detected. Finally, operational efficiency gets a boost. 2. Behavioral analytics in SASE frameworks improve threat detection and reduce false positives, increasing operational efficiency by 30%. UEBA, or User and Entity Behavior Analytics, analyzes user and entity behavior to enhance security monitoring. The approach has really evolved, moving from static rule-based systems to dynamic behavior-aware protection with UEBA. For comprehensive monitoring, UEBA analyzes user and device behavior application and network behavior to establish operational patterns. And with machine learning application, UEBA uses machine learning to compare user behavior to baselines instead of relying on predefined rules, all in real time. This has led to increased threat detection. UEBA implementations have increased threat detection by 76% and reduced false positives by 65%, plus identity fraud prevention benefits as well, since behavioral analytics can detect account takeovers and synthetic identity fraud by assessing users' familiarity with billing addresses. Integrating zero trust architecture is made much stronger with behavioral analytics. Continuous verification beyond just the initial authentication really strengthens zero trust security models. With continuous monitoring, behavioral analytics detects suspicious activity throughout user sessions, not just at login. Security decisions that consider behavioral context and identity verification create more adaptive and precise access controls. And yeah, data-driven insights from behavioral analytics help define and refine micro-segmentation policies, ultimately creating more effective security boundaries based on usage patterns. Implementation methods, require some strategic planning to really integrate behavioral analytics into SASE environments. First, you need to gather data from network devices, security systems, identity management platforms, and applications so you can get full visibility. Then you want to use a centralized analytics platform to correlate data from multiple sources, because that helps you find patterns that might not be obvious if you're just looking at isolated events. And of course, for practical analysis, your security logs and networking logs and metrics should always be high quality, detailed, and consistent. Now, when it comes to considerations for deployment, a phased implementation is usually the way to go. Start by monitoring your most critical systems, then expand coverage as your baseline behaviors and analytics get better. It's also important to integrate behavioral analytics with SIM, XDR, and other security platforms to actually improve their capabilities instead of just creating more isolated systems. And don't forget about user segmentation. Creating audience segments and personas lets you tailor behavioral analysis to different user groups, especially since they'll have different roles and access needs. For real-time response, automated remediation is key. That means isolating affected systems or maybe requiring additional authentication when there are high confidence threat detections. Prioritization is also important. Using behavioral risk scores helps you prioritize security alerts, so analysts can focus on the most significant threats. And finally, continuous improvement is essential. You'll want to regularly review and refine your behavioral models based on feedback from the security team, so you can improve detection, accuracy, and cut down on those annoying false positives. So, behavioral analytics integration is without a doubt powerful, but also, pretty complex. Privacy concerns are a big deal here. Organizations need to find the right balance between keeping things secure and respecting user privacy when they're monitoring behavior. And, behavioral analytics systems might actually generate false positives at first, especially during the learning phase, until there's enough data to set up accurate baselines. Security analysts really have to understand both the technical side of SASE and the actual behavioral patterns to make all this work effectively. But the upside is big behavioral analytics can boost the security of the SASE framework by providing more accurate threat detection, cutting down on false positives, and enabling adaptive security controls that respond to changing risk conditions. Basically, this integration moves security away from static defenses and toward intelligent, behavior-aware protection that can adapt to new threats in real time. Organizations have to tackle several significant SASE implementation challenges if they want to get the most out of security and operational efficiency. Some of these weaknesses are especially tough and can really affect long-term adoption and overall effectiveness. The complexity of SASE's infrastructure integration is honestly a pretty big flaw. Issues with legacy system integration can slow down SASE implementation and even compromise security. And when organizations make unplanned transitions from traditional network architectures to SASE, it just makes things even harder. This integration challenge shows up in a bunch of ways. For example, there are multiple handoffs where traffic has to go through various cloud security points of presence, which makes troubleshooting pretty tough. Then there's management layer integration. Teams need to set up tunnel traffic routing rules and get all the management interfaces working together. And don't forget, legacy system compatibility. Tying SASE into existing technology stacks is just difficult for a lot of organizations. Some remediation strategies include rolling out SASE in phases so critical systems can transition while still keeping legacy infrastructure working. Instead of making huge sweeping changes, organizations are now going with vendor-agnostic solutions that can adapt to whatever technology they already have. Another weakness is, incomplete enterprise-wide visibility into sensitive data. SASE provides excellent visibility into cloud data, but honestly weaker visibility into on-premises data stores and endpoints. Attackers can definitely exploit these blind spots. The Gartner 2021 Strategic Roadmap for SASE Convergence actually lists sensitive data visibility and control as one of the top 5 SASE solution gaps. Endpoints are the primary attack vector for malicious insiders and external threats, making this limitation, pretty concerning. Organizations are now adding endpoint data loss prevention solutions to SASE to monitor and control sensitive data across locations to address this weakness. Protecting endpoints that may remain vulnerable after SASE implementation helps close those critical security gaps. Multi-tenant SASE deployments raise security concerns, especially at the hypervisor level. If hypervisor security is compromised, cloud-based SASE implementations with multiple organizations sharing infrastructure can cause isolation vulnerabilities. SASE servers are also vulnerable to new attacks and unpatched zero-day vulnerabilities, making them real targets for sophisticated threat actors. The shared infrastructure model also means denial of service attacks can disrupt multiple customer services. Server-side attacks can compromise many organizations' security. Multi-tenancy risks can leak data or allow unauthorized access if isolation mechanisms fail. Confidential computing technologies can create hardware-based trusted execution environments, or TEEs, to protect SASE components from unauthorized access. The operating system or hypervisor root user cannot inspect SASE process data because these environments encrypt memory. Inefficiently distributed or overloaded points of presence can cause latency in SASE architectures. Performance really suffers when traffic has to be backhauled through points of presence that are far from users or target resources. Some of the main performance issues with SASE include things like cloud security routing, which increases latency, and using cloud security services, which can actually limit bandwidth. There's also content inspection, encryption, and processing overhead to think about. Organizations address these challenges by strategically deploying edge nodes, using content delivery networks, choosing providers with global point of presence networks, and optimizing network paths to reduce latency. Plus, load balancing multiple security service instances helps reduce processing overhead and maintain performance even during peak demand. SASE's convergence of networking and security functions really requires breaking down organizational silos, which is both culturally and operationally complex. Security and networking teams that have operated separately often struggle to de-silo, and honestly, a talent shortage just makes SASE even more complicated because many organizations lack the necessary expertise. SASE implementation and management really do require both networking and security know-how. So organizations are addressing this weakness by building teams with networking and security experts, training employees to gain that expertise, using managed service providers for SASE implementation and management, and creating collaborative workflows that foster departmental cooperation. SASE promises long-term cost savings, but organizations often struggle to manage the initial investment and operational costs. Most SASE solutions' point of presence infrastructure requires global deployment and redundancy, continuous upgrades, and consistent uptime, which all drive up costs. As more traffic flows through SASE systems, egress costs, the fees for moving data out of cloud networks can rise quickly, especially for large organizations or those with heavy data transfers. Before implementation, it's really important to conduct cost-benefit analyses, carefully select vendors based on pricing models that match organizational usage patterns, and optimize traffic to reduce unnecessary data transfers and egress costs. Several promising technologies and methods could improve SASE's weaknesses. AI-powered automation, for example, will optimize configurations and troubleshoot integration issues in SASE deployments. Increased edge computing capabilities also help reduce latency by processing security functions closer to users. Standards-based APIs for SASE components will simplify integration and reduce vendor lock-in. Integration testing frameworks using purpose-built testing tools will allow SASE deployments to be validated across diverse environments. Acknowledging these weaknesses and implementing strategic remediation strategies can really help organizations maximize SASE benefits and minimize its drawbacks. SASE may solve many of these issues through technological advancement and industry standardization, but still, organizations must be vigilant in addressing weaknesses through thoughtful implementation and additional security.